All right. Well, good luck.
All right, everybody, here we go. We're going to talk about inverse functions in the Blitzer book. If we're in the Blitzer book, that is section 2.7. Okay, so what does an inverse function look like to begin with? So first of all, we're going to say there's a function g of x that is the inverse of an original f of x. And the math notation here is IFF, that stands for if and only if f composed of g of x is equal to x. So this is why we needed to do those combination problems first, so we can know what that looks like. So f composed of g of x and equals x, and g composed of f of x equals x. So what that means is whenever I take these two functions and I do the different compositions, remember this is like fog f composed of g, I'll get out an x, so everything will drop out except for the x. And then when I do the GOF, g composed of f, same thing, I get out an f. I'm sorry, an x, okay? If this happens, then what we say is, we call g of x f with this little -1 in the exponent of x. Okay, that literally we say that f inverse. That's how we say it. Okay, so this little kind of exponent notation, but with a negative, when you see that somewhere, that means an inverse. So, okay, we have an original f function. We figure out what the inverse function is, which we're going to figure out how to do that in just a second. And once we have that inverse function, we call that guy, g of x, we'll call him s inverse. This is the inverse for the function f. Okay, so here's some examples. Example 1. It will say something like, show that f of x equals 3x plus 2 and g of x equals x minus 2 over 3. Okay, so that guy's a little rational function, are inverses. Okay, show that these two functions are inverses. So when you see that, the way you're going to check it is by doing these compositions. You've got the f of g of x, and you've got the g of f of x, and we know how to do those now. So we should be able to go back and look at that and plug things in. And when we're finished, we'll say, okay, we got x out, so it's an inverse, or oh, we didn't, so these two are not inverses. So let's see. I'm going to do the fog guy first. F of g of x. So remember that the way this works is I say, write the outside function, which was the f guy, was the outside function. So it's 3 times x, okay, plus 2. But instead of writing the x, I like to put parentheses. You can go ahead and substitute in if you're that good, then go ahead. But I'm going to say something's going to replace the x guy here. It's the g, okay, all of this that is equal to g is going to go inside, right? Because the g guy is on the inside. So that guy goes right there. So that's going to be x minus 2 over 3. Okay, so plug it in everywhere you saw an x, and then we just simplify, right? Well, when we go to simplify this guy, it's actually kind of nice because the 3 is being multiplied by the x minus 2 over 3. So the 2 3s are going to reduce. And then we say, well, f of g of x is equal to, these went away. I still have in the parentheses x minus 2, and on the outside a plus 2. But we know that minus 2 plus 2 is 0. So that is just going to be x. Oh, look, everything dropped out. The multiplication and the division by 3, those were opposite operations. So those went away. And then the minus 2 and the plus 2, those are opposite operations, so those go away. So when I knock it all out, what I'm left with is just the x. Okay, so that's what we mean by everything else is just going to fall out. It's going to go away. And when I'm done, I'll just have an X. So unfortunately, though, I'm not finished because it had to be an and statement, right? These are inverses if and only if, so I have to do it both ways. This way, well, I'm good there. I got to check there, right? And this way. So in order to be absolutely certain that these two are inverses, in order to show it, I have to go the other direction. So I have to do the Goff guy also, G of f of x, okay? So again, I come up here, I say, what was my original G? He's on the outside. So it's gonna be something, that's equals, something minus 2 over 3. And whatever I'm plugging in, I'm gonna plug it in where I see an X, right? So this is where my X guy was. This is what I'm plugging in. So the 3x plus 2 is on the inside. It's going to go inside here. So what does that look like? Well, when I plug it in, G of f of x equals parentheses. F of x guy is 3x plus 2. Okay, minus 2 over 3. Well, this actually looks very similar to what we just did, but you actually have to do your order of operations and do it in order, right? So I cannot divide the 3's right now like I did earlier. Earlier, it was multiplication was on the outside, so I can multiply that in and divide. But here I look and I say, oh, look, this all on top is one big grouping thing. So on top, I have to do all of that first before I can get rid of this division, okay? So, okay. On top then, what's going on? 3x plus 2 minus 2. Well, that's plus 2 and minus 2. Those are opposite operations, right? Those are going to go away. And what's going to be left on top is a 3x. And what's on the bottom was a 3. I uncovered it. I used my famous hand covering technique. And then we just look at that and we go, well, 3 divided by 3, that's a 1. So this is just 1x, or I can just write it x. And sure enough, I got the X there as well. So these guys are inverses. Yay. So X there means I have an inverse. Nice job. So they did find that. Okay. So that's how you would check to see if things are inverses. And then, of course, the next step that they're going to throw at us is, well, okay, I gave you 2, see if they're inverses. We did that. Now let me give you 1. And you can find the inverse, okay? So example 2 says, find the inverse of f of x equals 7x minus 5, okay? This is my original guy, right? Okay. So what I'm going to do is I'm going to do some arithmetic on one side, and I'm going to write the steps on the other so that we can see what's going on here to find the inverse. Giving myself a little bit of space here, sorry. So I'm going to have kind of 2 columns going on. Over here on the side, I'm going to write what's going on. Okay, so the first thing you need to know is, wait a minute, f of x is the same as y, right? Don't forget that f of x is always the same as y. So this is really y equals 7x minus 5, because I can just get rid of that f of x and write a y equals. So that's important because my first step says, here's my steps. Number 1, switch your x and y. Okay, so if you had the f of x there, then your very, very first step is get rid of the f of x and make it a y. Okay, so switch your x and y. So here we go. Here's step number 1. I've got y equals 7x minus 5. I'm literally going to just move this variable over here and move that variable over there. Swap them. Okay, so that is x equals 7y minus 5. So the idea here is that we're looking for inverses, which means everything's kind of an opposite operation. So in order to undo the math that's there, switching them will help us. Okay, so that's step number 1, switch the x and y. Step number 2, now that you have done that, solve for y. Okay, well, we've done that before. So we want to get this guy by ourselves. So I'm going to add 5 on the other side of the equal sign, right? 7y, these go away, equals x plus 5, because I added 5. Okay, am I done solving for y yet? No, I've still got a number out in front of that y. So it's a 7, it's being multiplied. I'm going to divide by 7 on both sides of the equation. And when I'm done, and I'm going to switch these around, I've got y equals 7x plus 5. I'm sorry, x plus 5 divided by 7. Okay, so all of that step number 2, right? So this was step number 1. This is step number 2. Okay, solve for y. Done. All right, everybody's good with that, I hope. Done there. Okay, let's move on. I don't want to scoot this too far if I don't have to. So step number 3 says what we're going to do is we're going to switch the y again, but this time we're going to switch it for f inverse of x. So I've got the y solved here. This is now my f inverse. So I'm just moving it back. So this is step 3. Okay, that matches over there. Okay, so that means that my original was 7x minus 5. My inverse is x plus 5 over 7. And you can kind of see in there that one had a subtraction, this one's got a multiplication or an addition. That one had a multiplication, this one's got a division. So you can kind of sort of see where they are opposite operations there going on. There's one more step, and it's just always out there. You always have to be aware of it and use it, right? So step number 4 is always check your domain for bad spots. And this happens a lot whenever I'm finding inverses because we had a lot of multiplication. So a lot of times we do a lot of division. So I got to watch out for this denominator. Now, remember, whenever you've got a denominator, what you're worried about is your denominator cannot equal 0 because that means you're dividing by 0. Well, can this 7 be a 0? And in my head, I'm hearing, no, Dr. Webster. So do I have any bad spots on this guy? No, Dr. Webster. So this is my answer. Okay, I don't have to say, but X can't be blah, 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 because it's just a 7 on the bottom. So I am okay. Oh, bless me. So sorry. I didn't mean to sneeze. I tried to freeze it before I stopped the recording before I sneezed, but I didn't quite make the air. I'm sorry. Oh, goodness. Okay, sorry about that. So sorry. That would be a funny blooper to bring out of the video. Not mean to sneeze on you guys. All right, so you can check those two. We had them. F of x was 7x minus 5, and f inverse of x is right there. You can do your fog and your Goff. So to check, find f of g of x, make sure it's equal to x, and g of f of x, and make sure it's equal to x. And when you're finished, those two guys are going to be both of them equal to x. That's when you know, okay? All right, let's try a different one because I know this was just a nice, pretty linear equation. Let's do something a little bit more difficult. So we're more along the lines of what we maybe will see on our homework or something like that. So this is, I'm going to skip one. This is actually out of the textbook for Blitzer. This is example 4, if you happen to have the Blitzer book around. So it says f of x equals x plus 2 over x minus 3. All right, so here we go. We had, oh, I'm looking for my steps and they're up here on the page, way up here. We need to switch the x and the y, but I don't have a y yet. So my very, very first step is make that guy be a y, okay? So now I'm gonna switch my x and my y. Now be careful because there's one x here, one y here and 2 x's. And when I swap those out, there should be 1 x and 2 y's, right? So swap my x's. So step 1, switch the x and the y. So that's what I'm going to do. Here I'm going to have x equals y plus 2 over y minus 3. There were 2 x's, now I have 2 y's. Okay, so there you go. And when I look at that, by the way, on this original guy, hopefully you know whenever you look at this original, what can't be y be, or what couldn't my x be up here? Let me, in the original, that's what I'm looking at. X can't be 3, right? Because 3 minus 3 would be 0. So that's a spot in the original functions domain. So I got to watch out for that. It's a bad spot. I can't have x equal 3. And now I'm going to keep on going. We switched them, and then step 2. Whole thing here. Step 2 was solve for y. Okay. So it's a little bit more complicated on this one because I've got this division. So how do I get rid of the denominator? The answer is you multiply by the denominator. It's technically on bottom, so I can put it 1 minus 3 on the top. And that way the bottom guy here and the top guy there will go away. But remember, whatever I do to the right-hand side, I have to also do to the left-hand side. So if I multiply over here by 1 minus 3 to make these disappear, multiplication and division are opposite operations, then I have to multiply on the left-hand side as well, right? Okay. So y minus 3 times x is equal to, that guy goes away, y plus 2. All right. Okay, so here we are with this, and then I need to solve for y. So I'm going to distribute this x through. He's on the back. If it bugs you that he's at the back, you can move him to the front. It doesn't matter. He's still being multiplied. So x times y is xy. X times negative 3 is negative 3x is equal to y plus 2. We're getting there. Now I'm trying to solve for y, so I'm going to move all the y's to the one side and move the x guy to the other side. So minus y, and this was a minus 3x. I'm going to plus 3x plus 3x. All right, these guys go away and those guys go away. You can do that in 2 steps if you need to. Xy minus y is equal to 3x plus 2. Okay, I'm almost there. Now on the left-hand side, I see 2 terms that both have a y in them. And so in order to get the y by itself, remember that's my goal here is solve for y. In order to do that, I need to factor that y out. They have a common term. It's called a GCF, greatest common factor. I'm going to factor the y out. When I pull it out of here, that leaves me with an x minus, when I pull the y out of here, that leaves me with a 1. So be careful about that. Make double sure whenever you multiply it back through. Yx, yep, that's the same. Y times negative 1, yep, that's the same. So it's kind of an unusual factoring step. We're not necessarily used to doing that. But that's how, if I have 2 terms added or subtracted and they both have y's in them and I want to get the y by itself, the way to do that is factor it. Okay, and now I'm almost done. So I want to get the y by itself. Divide by x minus 1, divide by x minus 1, minus 1. And I don't want to go onto another sheet of paper, so I'm going to go right up here. Okay, so what I've got, these 2 go away. Y equals 3x plus 2 over x minus 1. Okay, just taking that, these went away, cover them up. Y equals all of this stuff. Okay, good. All right, so now I have y by itself, and the step 3 was always swap y for the F inverse, because we're done, we found it. So the F inverse is 3x plus 2 over x minus 1. And don't forget your very last step, step 4, check the domain for bad spots. Okay, and if you remember, how do I check the domain for the bad spots? I can take this denominator, I can pull it out, I can say x minus 1 cannot be 0. Why? Because I can't divide by 0. That gives me an undefined statement or an error or no solution, however you want to think about that. And so I've got x minus 1 can't be 0, so I can solve for that x, just add 1, right? This goes away. X cannot be 1. And if you look at that, it should make sense, right? If I had 1, I'd have 1 minus 1, and 1 minus 1 would be 0 on the bottom, and that would be undefined. So in my inverse, x can't be 1. Okay. In the original, I couldn't have x equal to 3. So I've got some domain spots on this one, and that's one of the things that makes this just slightly more difficult than what we had to begin with, right? So the other ones that were linear or whatever. Okay. So that's kind of the idea behind all of these. I'm going to give you one more example just so that you can think about it. I think, am I up to example 5? Yeah, example 5. I think I skipped like example 3 out of the Blitzer book. I didn't want to do it. Too much duplication. But what if f inverse of x is equal to the square root of 2x minus 5? Okay, that's what I want to know. So I'm going to assume that you had an original function and you found the inverse, and this is what you found to be the inverse. So what if that is what you have? Okay. You get there, you get through step 1, you get through step 2, you solve for y, you change out step 3, change the y for the f inverse guy, and you've got this, and you need step 4. That's what I'm worried about, is step 4 here. So I'm not worried about y'all switching the x and y and solving for y. Okay, I feel like we can do that. But what about this? What are the bad spots in the domain? That's what I want to know. And how do I figure it out? Okay. So we spend a lot of time in college algebra classes and different algebra classes talking about the fact that we can't divide by 0, so the denominator can't be equal to 0. We watch out for those bad spots in the domain, but also there's another thing that can mess you up, and that's what I want to worry about here. Okay. The question is, where else can I have a bad spot in the domain? So there are 2 ways. We already know you can't divide by 0. Right, we already did that one. But the second way is that we can have an undefined statement is you can't take an even numbered root, so be careful about that, even numbered root of a negative number. Okay, so those are the 2 bad spots that you got to worry about. An even numbered root of a negative number. And so when I look at this problem, let's talk about that. Even numbered root means like a square root or a 4th root or a 6th root, right? Okay. Why is this guy and why am I worried about him? Well, he's a square root. Technically, what that means is there's a 2 right there that's sitting inside of that root. And that is called our index number. Okay, so that would be a square root. If it was something like, what if we had, so I'm going to talk about this. You can't take an even numbered root of a negative number. What if I had the cubed root of negative 8? Well, first of all, that's the cubed root, right? So that's an odd numbered root. It's not even up there in the index number. So I'm not worried about it. And what this means is find some number that I multiply by itself 3 times and it gives me negative 8. So the cubed root of negative 8, we actually can do that. Negative 2 times negative 2 times negative 2. That's okay. Because a negative times a negative is a positive, and a positive times a negative is a negative. So that gives me the negative. Okay, that works. And then 2 times 2 times 2, well, that's 2 times 2 is 4, times 2 is 8. That works. So I can take odd numbered roots of negative numbers. That's why this says very clearly even numbered roots. Okay, so let's do the same thing But let's say, what if we had the square root of -8? I normally don't write it, just for emphasis purpose, I'll write a 2 there, but square root, we don't normally write it. We assume that we're talking about something that is that way. Well, this becomes undefined because if it was a positive number times itself, so what does this mean? Something times itself gives me -8. Well, a positive times a positive is a positive. Or if it was a negative number, then a negative times a negative is a positive. So there's no way I can multiply something by itself and get a -8. It would have to be a positive and a negative, right? So that's undefined. So it doesn't work. Okay. So this guy does not work. And eventually what you found out in your algebra classes, I'm sure, is that we have a particular letter that we introduce and we say, well, let I equal the square root of -1, right? Well, if I equals the square root of -1, then I can deal with this, right? So this brings in what we call imaginary numbers. And I'm sure you've dealt with those before. Imaginary numbers. Okay. So that's why we say this is undefined, or you might hear somebody say there's no real answer. And that's because it pops us out of the real numbers and marks us over into the imaginary numbers. That's why we can't do that. Okay. So those are the things we're worried about doing when we see an even numbered root, a square root, a fourth root, a sixth root, an eighth root, okay, even those even numbers up here, then we're going to worry. So then we got to check, okay? If it's a 3 or a 5 or a 7 up here in the root as the index number, I don't care, right? It's only those even numbers, okay? Because if I have one of those, we know that's going to knock us out of real numbers. It's going to make it be an imaginary number. And then I'm going to have a no solution or something like that, right? Or I have to bump out the i's and figure out that stuff, which we will deal with i's a little bit later when we get into quadratic functions, okay? But we're just not going to deal with them now. But we are going to say, hey, I got to worry about this spot in my domain. So let me come back up here to my original question, which was, what if my inverse is the square root of 2x minus 5? Then what I'm worried about is I have an even numbered root, right? And I have some stuff in here that has an x, and I can't let that total thing that's in there can't be a negative number. So let me rewrite this just so that it's close at where I am. So here's the f inverse. We said it was the square root of 2x minus 5. And what I would say is this stuff on the inside cannot be negative. And it's all the stuff, right? All the stuff together cannot be a negative number. So let me think about that. Okay. What if x was 5? 2 times 5 is 10. 10 minus 5 is 5. I had to get the square root of a 5. It's not a pretty number. It's irrational, but at least it's not negative. So I can take the square root of 5, right? That's not a problem. The only problem I have an issue with, the only time I have an issue with is when all this stuff here is negative. So what I want you to do, just like on the division problems, we just deal with the denominators. We're just going to deal with the stuff on the inside because that's what I'm worried about. So what we're going to say is 2x minus 5 cannot be negative, okay? Cannot be negative. It could be 0 because if I took the square root of 0, square root of 0, 0 times 0, I'm okay. I'll just get a 0, right? So that would be all right. 0 is not a problem, but a negative number would be a problem. So it cannot be a negative number. That's what I'm going to say here. Okay, so what am I going to say? 2x minus 5 has to be greater than or equal to 0. The greater than part means it has to be positive, right? Because I said it can't be negative, not negative. The greater than makes it positive, or equal means I'm okay with it being 0 also, right? Well, then you're going to look at this guy and go, oh, that's just a little inequality. I can solve that just like I solve any other equation and we'll be okay. So here we go. We want to get the x by itself. I'm subtracting 5, so I'm going to add 5. 2x is greater than or equal to 5. And then I'm multiplying by 2, so I'm going to divide by 2. Divide by 2, divide by 2. Okay. So x needs to be greater than or equal to 5/2. Or if you don't like that, you could say x is greater than or equal to 2.5, because that is 5/2, right? So in other words, when I picked 5 earlier and I stuck it in there, I was okay, right? 5 times 2 is 10, minus 5 is 5. That was okay. That's because 5 is greater than or equal to 2.5 or 5/2. No problems. What if I put in a 0? So can x equal 0? 2 times 0 is 0. 0 minus 5 is -5. Can I take the square root of a -5? No, that's bad math, right? That's going to cause me a problem. So no, x cannot be equal to 0. That would be a bad spot. In fact, anything that's less than 2.5 or 5/2 is a bad spot. So the way you'll write this for your domain piece is just like this. X needs to be greater than or equal to 5/2. So those are the ones you got to worry about. You can't divide by 0. Here it is, way up here. You can't divide by 0, and you can't take an even numbered root of a negative number. So here we are, we take it, we make it greater than or equal to 0, we solve, we figure out what my bad spot is in the domain. In this case, it's lots of bad spots, right? Because 0 is a bad spot, 1's a bad spot, -3 is a bad spot. Anything smaller than this is bad. So there's a whole bunch of stuff in here I cannot put inside of that radical. Cannot take the square root of this stuff whenever x equals, say, -10. That would be bad. 2 times -10 is -20. -20 minus 5 is -25. And you're thinking, oh, yay, 25, but not negative. Negative makes it so that it pops me out into the imaginary numbers, and that is not going to be a real solution. So we say that's undefined. That's my bad spot in the domain. All right, that's it. I hope that makes sense for inverses, and good luck on the 2.7 homework.